Hey, welcome back to another episode of Hot Hardware's 2.5 Geeks. We're back. There's actually 4 of us here, but you can't see one of us. So it's kind of like 2.5 Geeks plus another guy. Chris Gettings behind the curtain on the panel, on the con for us. And we've got Marco and we've got Paul. How you doing, guys? It's been a while. It's good to see you again. How's everybody doing?
Doing pretty good. Can't complain.
Same here.
Paulie, you've got
good to be back since I missed the last episode.
You've got some extra special threads on there, Paulie.
I do. I wore my fancy clothes for this podcast. You know,
that
my fancy new bow tie?
Is that like Celtics green, or is that like a St. Patty's thing, or what?
It's a St. Patty's that just happens to also be Celtics green. It's not Celtics gear, but you know,
it could be.
It's close enough.
Yeah, and Marco's sporting his GeForce 10 shirt.
That's right.
Nice. We all got the
spring day here.
My only branding for this is my GeForce 10 koozie that I have around my Rebel Rouser IPA from Samuel Adams. Yeah, that's an NVIDIA GeForce 10 koozie. But you won't see it often until I tip it, because it is happy hour now, right? I mean, this is happy hour.
It's happy hour somewhere.
Damn it. Yeah. It's always happy hour somewhere. Well, thanks again for joining us, everybody. It's good to be back. We're here to talk about the latest headlines in tech, and certainly lots of stuff going on these days. I mean, if it isn't AMD or Intel, it's NVIDIA keeping us busy. All kinds of great stuff to talk about. Marco, you've got something new from the folks at Intel that came out earlier this week, and new in the land of solid-state storage, the Optane SSD. Tell us what you know and if it's worth spending our hard-earned jack on, I guess, right?
Well, it seems it'll be worth spending your hard-earned jack on. We don't know just yet because we haven't done any independent testing, but Intel has announced and started taking orders for the Intel Optane SSD DCP4800X. You know, an engineer named this thing.
Alphabet soup.
Yeah, so this is the first solid-state storage device targeted at the enterprise that features 3D cross-point memory technology. So back in 2015, Intel and Micron jointly announced this 3D cross-point memory, which is essentially something brand new. It's sort of like a cross between NAND and DRAM. It has properties of both, but it uses all new materials, all new structure, and you essentially get almost DRAM-like performance, but it's non-volatile like NAND flash memory. Now, this particular drive that Intel announced, the SSD P4800X, is going to carry a price premium. It's about 3x a price premium versus other enterprise targeted solid state drives. A 375 gig model is going to sell for about $1,525. Now, we haven't run independent tests, but we have some performance data provided by Intel, and we've had some intimate time checking out the device. We just haven't written an article yet, don't have one in the lab. I was at Intel, got to see it in action, got to see some really cool demos. And this thing is kind of crazy. So if you were to look at the specs, it might not seem, too out of line versus other enterprise SSDs. For example, 4K random IOPS are in the 550 to 500,000 range, which you've seen that before. And with a mixed 70-30 workload, up to 500K IOPS, again, not out of the realm of other drives, but that's at a really low Q depth, between 1 and 8. And the endurance is really high as well. So you can have up to 30 drive writes a day. And with this particular drive, the 375 gig drive, that'll equate to 12.3 petabytes over the warranty life cycle here. And what's really interesting is that under load, access times are really, really fast and consistent, sometimes in the neighborhood of, 77 times better than a NAND flash drive. Now, sequential transfers, I don't have any hard numbers to share, but those will probably lag behind some of the faster enterprise SSDs out there. But responsiveness under load is way better. between 12.5 and 35 times faster than an enterprise SSD. If you check out the second page of the article, there's some Intel supplied graphs that kind of show the delta. And what you'll see is that NAND-based drives have, they have low latency, but it's sort of all over the map depending on the workload. Whereas the Optane drive, it's just tight and super fast and consistent all the way across the deltas here. It's really an interesting product, and we can't wait to check it out.
Interesting. So sequential throughput isn't that peppy, but fast access time. So theoretically, that should translate to what for the end user? You're talking about a more responsive system, something that feels faster. Or are we talking about more? I mean, this is an enterprise class drive, so is it really more of enterprise type applications like database, storage and stuff like that, in a server or workstation that would benefit from this?
So not only is it really fast access times, it would help if I could speak, but it's consistently fast access times, even when the drive is under a sustained write workload. So even if the drive's getting hammered on by multiple users, the access times for other people or other sessions hitting it are still super fast all the time. And because it's sort of tuned for lower queue depths, if you were to look at a typical SSD today, lots of times those fast IOPS numbers are reported at queue depths of 32 or maybe even higher, which rarely ever happens in the real world. Queue depths typically fall between like 1 and 8. So if you look at really low queue depths with most NAND-based drives, performance is much, much lower than the reported numbers in the specs because they're reporting specs at higher queue depths. So in real world workloads, even under sustained pressure, these drives should be far more responsive. And sequential transfers should still be good, just not as fast as some of the fastest drives.
Gotcha. Interesting. So there is a usage model with these, like a setup and implementation with the Optane SSD in front of another piece of storage subsystem, whether it be hard drive or solid state drive. Can you comment on that?
No, so that's not this drive. That's something else that
right.
we have to talk at
in the future is what I meant. Yeah.
But so there is another setup with this drive. Now Intel's going to sell it in kind of two packages. You can just buy the hardware, or you can get the hardware with a piece of software. Let me make sure I get the name right. Give me 1 second here. Intel is calling it. Let's see. Give me 1 second. I am forgetting the name. It's something really simple, though. All right. Whatever. So basically, Intel is going to sell it in two packages. One, again, is just the hardware, and the other is with a piece of software that sort of acts like middleware. Like consider it like a hypervisor for your storage and memory. Right. And what it'll allow users to do is configure one of these drives to behave like RAM. So if you had a server, you can take this 375 gigabyte drive and basically allocate it like memory. And now all of a sudden you have a server that can handle much larger data sets. So there's some interesting possibilities that happen there. This is definitely an enterprise thing, but you can now, instead of spending tons and tons of cash on huge amounts of DRAM, you can use this thing as pseudo memory. It's really an interesting setup.
Right, gotcha. So actually, Chris, go back to that last image you had up there with the client SSD. And Marco, I don't think we're talking out of turn to say this is coming. We can't say much about it. We don't know much about it yet. But in the client implementation or the consumer implementation, motherboard vendors are already sort of provisioning for support. Kaby Lake has support for this technology in some shape or form. In that scenario, are you talking about caching, or are you talking about, again, this drive being the drive in the system?
I'm not sure what I'm allowed to say, so we're just going to say that a client SSD is coming.
Okay. I think, okay, fair enough.
That's as far as we should say.
I'm making Marco sweat. Yeah, no, it's fine. That's fine. I think there's a couple of different ways you can skin a cat there too. But interesting stuff from Intel. It'll be interesting to see how this pans out at the client level. There it is. That's something that was actually it was sort of announced but not discussed much by Intel. So we're not telling you any trade secrets there. But how that'll be implemented at the client level, at the consumer level, will be interesting as well, obviously, for folks watching now. So good stuff. You let's see, you've got how big was that drive you tested, the 4800?
I didn't test it.
I'm sorry.
So it's a 375 gig. There are other models coming as well. There will be a 750 gig and a 1.5 terabyte, but they're coming later. The 375 gig now is available. Became available March 19th in limited quantities with broad availability in the second half. The 750 gig drive is coming in Q2. And the 1.5 terabyte in the second half of the year. And I should also mention they're available, or they will be available in add-in card form factors or U.2 form factors.
Cool. Yeah, no, I see all the configurations there. So coming to our labs someday, but not yet.
Not yet.
Cool. Excellent. Paul, what are your thoughts there? Do you want one? You don't have a data center. Right?
I was going to say, it's funny timing. I just sold off my data center, so I don't know what I'd do with one of these just yet. But no, once it reaches the consumer, once it trickles down into the consumer space, it'll be a lot more interesting for people like me. Right now, it's just kind of, gee whiz, that's cool, neat.
So what's looking at the first batch of drives that are coming, it's sort of like fitting a square peg in a round hole. The performance of these drives, these particular drives, are going to be good with very, very good with some workloads, but it does not exploit the full potential of that 3D crosspoint memory. This stuff has the potential to really revolutionize system architectures, because theoretically, if a system was architected to use this stuff as a single pool of RAM and storage, and it's really close to the CPU, and with a much wider path to the CPU, you can get some crazy performance, and it's non-volatile. So I think this first batch of stuff is sort of like, hey, it works, it's coming out, but in the future, 3D crosspoint memory could make for some really revolutionary changes.
Thank you. That's what I was trying to get to, and I didn't want you to break any embargoes. Appreciate that. Yeah, exactly. That's what I was trying to get at with this thing. It's an interesting technology for sure. And Intel and Micron have developed that memory technology together. So there's some critical mass there beyond just Intel. There's Micron, two very big players in non-volatile memory, going at this thing. So good stuff for sure. Let's move on to squarely to the consumer space and talk about NVIDIA's new GeForce GTX 1080 Ti. I'm sure a lot of folks by now have seen the reviews, the unboxings, and all that good stuff. Marco, you've tested it out. I actually attended the NVIDIA's Editor's Day for the product, and very impressive. NVIDIA's GeForce GTX 1080 Ti actually comes out, and it actually stepped up ahead of where we expected it to. We expected a 1080 Ti to come out, frankly, once we saw the Titan X, Pascal Titan X, hit the scene. We expected this product would be forthcoming, but we didn't expect it to be so powerful, so performant versus the Titan X. And it's actually slightly faster than a Titan X in most cases. It is NVIDIA's fastest memory technology that's on board, a new faster GDDR5X memory developed again here by Micron. It's a little bit faster signal, or a little bit better signal integrity for faster interface speed, and the same number of CUDA cores, a little bit higher core clock, and as a result, yes, this thing, lives up to its specs. It's actually slightly faster than the Titan X in most cases. What's interesting about it is there's a cluster of 8 ROPs that's been disabled. And so that's the render output units, and they also connect to memory to the frame buffer. And so there's actually 1 gig of less of GDDR5X memory. So an 11 gig card sounds kind of odd, but it's enough to get 4K, no problem, to cover your 4K memory requirement for 4K gaming. And this card certainly can handle that. It is also a really good overclocker as well, and that's because NVIDIA retooled the thermal solution, the vapor chamber and the heat sink array with a little bit more surface area as well, and the voltage regulation on board as well, the power supply on board the card. So you've got a little bit better headroom for overclocking, a little bit better base speeds, core and memory, and actually it runs a little quieter as well. And so we showed this thing over various resolutions and various game engines, whether it be Middle Earth: Shadow of Mordor, DX11 title, where it's something like, it's like 5% or so faster than a Titan X. When you get up to 4K levels, it's a little bit closer, at higher resolutions. Moving on to like Tom Clancy's The Division, a DX12 title, ultra preset 2560 by 1440. Again, you're talking about a 5% or so in that neighborhood advantage over a Titan X, significantly faster than a standard 1080. I think on average, 30 to 35% faster than a 1080. And again, when you scale up to 4K, that actually, interestingly enough, in DX12, the 1080 Ti actually spread its, or I should say, extended its lead a little bit to about to almost a 10% edge over the Titan X. So it's really an interesting card in that NVIDIA came out with this thing. They upped their fastest, most expensive card at $1,200, and the kicker is it retails for $699, and the thing is sold out everywhere. Well, I should say NVIDIA is doing very well with it. You probably can find them, but they are rumored to be, really taxed in the supply chain. So, Marco, what are your thoughts on this this new beast from NVIDIA, and I guess potential competition forthcoming from AMD?
I think the 1080 Ti kicks ass. It's really a weird configuration though. So if you look at the Quadro P6000, the 1080 Ti still isn't the full implementation of the GPU on here. There are still CUDA cores disabled, and then they also disabled that that memory channel and ROPs. So you get that weird memory configuration of 11 gigabytes.
Quadro full fat Pascal, you mean, right?
Right. The Quadro P6000 is the full implementation of the GPU. Now, I'm sure it yields lower, and maybe it's just the quantity is so limited that they're not going to launch a consumer card at only $699 and have enough. But theoretically, if NVIDIA wanted to make an even faster variant based on this GPU, they totally could. Yeah. But now, to answer your question versus AMD, it's too early to say how it's gonna compare to Vega. Some Vega benchmarks have leaked and showed it sort of competing with a regular 1080. And if you look at the 1080 Ti versus a Fury X, there's some instances where the 1080 Ti is literally almost twice as fast as a Fury X. So the target for Vega has to be very high. Has to be 2x a Fury X to catch a 1080 Ti or surpass it. So tough to say. I don't think, based on the rumors and the stuff that's leaked, that the first Vega cards are going to be this fast, but who knows?
Yeah.
It's all rumor and speculation right now.
Yeah, and I think anything that's leaked right now from AMD's side that's gotten out the door is really early, and to expect it to go toe-to-toe with a highly refined implementation of Pascal at this point with the 1080 Ti would be unrealistic. But yeah, it's I guess what I'm thinking of is it's just interesting how AMD had a gap to close, and we'll get to this with Ryzen, right, on the CPU side, and now they clearly have a gap to close, coming from Polaris and the RX 480, and then their fastest card, Fiji with the Radeon R9 Fury. They have a significant gap to close versus NVIDIA on the GPU side. On the high end, maybe not so much in the mid-range. So some work to do there as well, and it will be interesting to see if they can recoup that as they have clearly with Ryzen in the CPU space.
Yeah, I mean, if it comes out and it's 80 to 90% of the performance, but at a lower price point, people are going to love it. So
people are going to be happy about that. Paul, sure. Are you jonesing for a 1080 Ti?
It's nice. I think NVIDIA was pretty aggressive with this one. Had they released this months ago, as all the rumors had said they were going to do, I don't know that it would have been quite as spec'd as it is now. I mean, it's basically a Titan X. I mean, to even say it's a Titan X Junior doesn't do justice to the specs. And specs for spec, it's almost a Titan X. So,
yeah.
And at half the price. Plus, it knocked down the price of the lower tier cards too. So, I think it was a smart, well-timed move by NVIDIA.
Yeah. Actually, we forgot to mention that the 1080 came down from $599 to $499, the standard 1080. So folks were pretty happy about that. And man,
except for the ones who just bought a 1080, they weren't so happy.
Right? Yeah.
NVIDIA.
Go back. Hopefully, your e-tailer or retailer had price protection. Likely not, though, right? Jeez. Yeah. No, that would smart, wouldn't it? But yeah, no, it's good stuff. And I mean, man, it seems like lately what's encouraging, and Marco, I know you're feeling this love as well, and Paul, you too. What's encouraging now is how much buzz and focus and resources, dollar resources are being poured into enthusiast PC, enthusiast computing, gaming, whether it be simple stuff like esports or real high end, super high resolution, high quality, high image quality gaming like you get with a 1080 Ti. That is just for folks like us, it's a breath of fresh air. It's across the board too. I mean, even monitors are, suddenly the monitor makers suddenly woke up and are innovating again. So I mean, it's every aspect of PC gaming is up there now. Yeah. I'm viewing this on a beautiful 34-inch curved display with NVIDIA G-Sync on board, Yep. Yeah, it was stagnant in the monitor space for a while too. Marco's like loving it because for a while there we were all thinking, man, the world's going mobile, and guess what? PC is it again, king, back on top, the desktop, right?
We've been doing this a long time, and we've seen the ebb and flow a few times over the years. And yeah, I was always bullish on the PC because when you need to get any kind of real work done, you're going to use a PC. When everyone said tablets were going to kill the PC, and not for people that actually have to do work on them, they're not. If work involves answering emails, maybe, but for lots of people, there's more. More intricate things that need to be done, and real work gets done on a PC, and it's also the best gaming platform. Plus, it's just freaking cool, so of course it's going to come back.
Yeah. It's funny you mentioned that real work. I personally can't even warm up to the hybrid 2-in-1. If I'm going to do work on a mobile device, I need a full notebook. I'm a bit of a masher on the keyboard, right? And those thin little detachable keyboards, I can do with maybe a 360-degree hinge in a notebook. That's nice and convenient. But I need a full keyboard to feel, at home and fully tooled for my computing experience to get work done. Are you guys in that boat? I know, Marco, you like your machines a lot smaller, or a little smaller than mine.
I can get by with a small machine when I'm on the road. I dislike the 2-in-1 detachable form factors, though. Like the floppy keyboards just don't work for me. But yeah, like a clamshell, or if it's a firm detachable that can be used in a clamshell mode, it would be fine for me though.
Uncle Paulie's a big PC guy, though, right? You like notebooks too, right?
Paulie likes them big.
Yeah, I'm still a fan of the 17-inch form factor, especially since we get increasingly higher resolutions. I don't want to, squint at my little 13-inch screen. So, yeah, I like the big laptops.
Yeah, man, and now you're getting 1080s and 1070s in those things, and full up, actually 4K gaming capable laptops, which is just insane to even think that, but.
Real 1080s too. It's not like the previous generation where the mobile didn't line up with the desktop variant.
Yeah, no, it's good stuff for sure. And let's talk a little bit more about the gaming PC. And Paul, you took a look at a very custom high-end rig from the folks at Maingear. Some friends of ours out of the scenic state of New Jersey, Kenilworth, New Jersey is where they're located. And you guys probably know the folks down there. Wallace Santos, the CEO, has been pretty busy these days, pretty present in the social networking streams, doing all kinds of stuff with Maingear. You took a look at the Maingear Vybe, which almost looked like a medium to small form factor PC, but actually it's not. It's rocking dual 1070s in that thing. So it's
this one is, yeah. The Vybe line, they call it a boutique build for the masses, which means, when most people think of the boutique vendors, they think they can't afford it because they have their premium PCs, the prices are jacked up. This one, at the time of the review, the prices started at $999. I was looking today. It's a little bit more expensive to get in the door. I think it's like $1,150 or $1,200, and that was for a Ryzen configuration. But I mean, these are to get your foot in the door. They're affordable and they're well spec'd. The one that we got, it's more of a sleeper machine because it's still the Vybe, but they loaded this thing up to where you're well beyond affordable. As configured, it was just over $3,400. This one had a Core i7 7700K processor in there, 2 GTX 1070s, 16 gigabytes of HyperX Fury RAM. Came with the external DVD burner, 512 gigabyte Samsung 960 Pro NVMe drive, so it's pushing data through the PCI Express bus. Had a 1 terabyte hard drive for bulk storage, liquid cooler, 860 watt Corsair Professional Digital Series power supply, and the coolest thing is they overclocked this puppy to 5 gigahertz. So I don't think they guarantee a certain level when you pay for the overclocking service, but they're certainly gonna push it as far as it will go. And this one, they sent it to us. It was at 5 gigahertz, and it chewed through the benchmarks just like we expected it would. The only systems it trailed behind were ones that had 2 GTX 1080s, or it hung right up there with older machines that had 3 980 Ti cards in there. It won some benchmarks and it lost some benchmarks to that one. But it's a really nice system. They built it inside an NZXT S340 case, which is not a huge tower. It's a mid tower, so it's kind of unassuming as far as what's inside. So to me, as far as Wallace Santos is a car guy, this is like a sleeper car equivalent. You look at it, you're not going to know quite how fast it is, but it screams. The point there is, whatever your budget is, they will build it for you. If you have $3,400 to spend on a machine, they'll happily put it together, and it will be immaculately assembled. That's another thing. I know whenever we post reviews like this, the comments that always come in was, well, why don't you build it for yourself and save so much money or whatever.
I love that.
Yeah, and I think we got one of those on this one as well. And that's true. If you build it yourself, you are going to save some money. But what you're getting here is a build quality that's hard to duplicate. I mean, if you can show the internal wiring on this, it's pristine. It rivals what Marco might be able to do it. I don't know that I could. It's very tightly wound, everything in there. And of course, you have the warranty for Maingear on all the parts and on the overclock system as well. So it's not as simple as just doing it yourself and saving some money. I mean, you're getting a premium system for your premium dollars here.
Yeah. Hey, Chris, if you can switch to page 2, there's a good demonstration of the build on that thing. And man, I'm just looking at the backside of the case. Just obviously, the front side of the case these days, with the way cases are built, they're designed to route the cables behind the motherboard tray and keep things out of sight. So it's neat and clean. That's not too hard to do. Neat and clean around the CPU area and around the graphics card. That looks great. But the backside, where all the cables are routed, looking at that, it's like, man, somebody took some serious time with zip ties and routing and all this different stuff, so that that thing is perfectly clean back there as well. That helps airflow and thermals back there. And You know,
and
even
that's not a cherry pick system just for reviewers either. I mean, if you order one of these, that's what it's going to look like.
Yeah. And if you look, you know, it's funny. People say, oh, you know, save some money, build it yourself. Well, you're going to spend an afternoon sleeving those cables, those red cables that you see there. That's seriously, you know, pre-prepped, you know, dialed in cabling going on. And so, yeah, it's a really well built system. Marco, you're smiling through this whole thing. And it's probably because we know that your OCD can build a machine like this, but not everybody can do that.
I know I'm smiling at the machine, but I'm not sure if it's Kyle from HardOCP, but someone from HardOCP just commented and said Marco is pretty tightly wound, and I'm so not tightly wound. I don't get it.
Oh yeah, we get HardOCP TV joining us on the cast here. Interesting.
I seem tightly wound because I spend half of my life trying to hold in jokes because that's my reflex reaction to every comment is to make a joke, and I try not to do that.
He's probably referencing the fact that I was challenging you to give us more information in the Optane, and you wouldn't give it up like a good boy. Maybe that's what it is. But.
Oh, maybe.
Anyways, yeah, no, yeah, it's interesting to see what the folks down at Maingear can put together, Paul. It's that's a great system. So $3,400 as configured. Again, what was the entry level price for this?
The entry level price is about $1,150, and I think that's for a Ryzen configuration.
Okay. Yeah, obviously you don't need dual 1070s, you know, and you know, 512 gig Samsung 960 Pro, and not even the Evo, the Pro version of the
we should SSD. We should point out too that the reason they went with two 1070s instead of a 1080 Ti is because that wasn't even announced or available at the time that they put this together and sent it to us.
Yeah, no, absolutely. Yeah, no, that's and a pair of 1070s is a pretty healthy configuration across a lot of different titles. Obviously, when you get to DX12 these days, things are a little dicey for multi-GPU, but for the bulk of games in the market, you're going to see some pretty tangible gains with a pair of those cards in there. As we did benchmarks, that thing lit up the benchmarks. It was either 1 or 2 in everything we ran it against, right?
Oh, yeah. Facebook screams on this.
There you go. Good stuff. Well, yeah, check out the guys at Maingear. If you're not a hardcore DIY person that can craft a beautiful system like this, like Marco can, jealous that we all are. I can't. I hack them together. I can make them run good, but they don't look pretty when I'm done. Not like Marco's. But these guys will do it for you. And yeah, good stuff. Any other parting thoughts? Were there any downsides to the Maingear Vybe? Anything that was sort of made you go Paul?
Well, the cost is an obvious one. I mean, not everyone's going to drop $3,500 on a system, and the overclock was maybe a little aggressive. It wasn't Prime 95 stable, and icons would sometimes take a little while to appear on the desktop when you're moving them, you know, from a USB drive or, you know, from place to place. But as far as our benchmarks go, it was stable throughout. I mean, whether I was playing games on it or benchmarking with our games or other programs, it never crashed or showed any other signs of instability.
Cool. Good stuff. Well, yeah. That's the Maingear Vybe. Check it out at HotHardware. We've got the review up. You can dive in. Paul's got copious benchmarks and lots of nudie shots of that beautiful system. So
of the system.
Awesome. Well, let's move right along. We're clipping along at a blinding speed here. Let's talk Ryzen finally, and there's a lot to talk about. Marco, you did our review of the Ryzen 7 1800X, the 1700X, and the 1700. We had all 3 CPUs in-house for testing, copious amounts of testing. And we also recently, since then, have launched a little bit of an overview on Zen architecture in the data center, a platform called Naples coming. So let's take it one at a time, knock them down one at a time. Talk about the consumer side, talk about Ryzen, and what are your initial thoughts? And then we'll all chime in and give our 2 cents as well.
Yeah. So initial thoughts are very positive. There's actually we can talk Ryzen 7, Ryzen 5,
Yes.
Naples, and a new rumor of an alleged 16-core desktop chip. So there's tons and tons of Ryzen-related news. So AMD Ryzen 7 series, this is the flagship desktop series for now, consisting of 3 chips, Ryzen 7 1700, 1700X, and 1800X. The top of the line is an 8-core 16-thread machine, base clock of 3.6 gigahertz, boost clock of 4 gigahertz, and then XFR, an extended frequency range boost clock of up to 4.1 gigahertz. The 1700X is a notch below that, 1700 another notch below that. The 1700, we should also note, is a 65-watt TDP CPU. The 1700X and 1800X are 95 watts. All of them are 8-core 16-thread, so the entire Ryzen 7 series 8-core 16-thread. Since we have so much to talk about, I'm not going to go nuts into the architecture. We've been talking about Zen for a couple of years now. Suffice it to say, with some workloads, the chip actually compares very well to Broadwell E. AMD had been making comparisons between an 1800X and a Core i7 6900K leading up to the launch. So that was part of our focus in the launch review. And in many workloads, the 1800X is faster. If you look at something like PavRay with ray tracing, or Cinebench, where it's really competitive, slightly faster. Yeah. In more varied workloads like PC Mark, it was also competitive right there with Intel CPU, which happens to be twice the price. But it's not all sunshine and roses. There was some interesting gaming scores. Now, a little pet peeve of mine, there's lots of talk online about subpar 1080p gaming. That is the wrong way to categorize this.
Oh,
it's subpar CPU limited gaming. If you were to throw a faster GPU in there, that it sort of would shift up the stack. When it's CPU limited, Ryzen is trailing the Core i7, not across the board, but in many gaming tests. Now at 4K, which essentially becomes a GPU benchmark because you're GPU bound, things kind of even out. But that's going to happen if your GPU is limiting performance. If your CPU is fast enough to feed it, that's where the bottleneck's going to be. So that's just something that people are sort of getting wrong. Now, with that said, I kind of saw an interesting Facebook post last night from Gigabyte that showed this huge increase in performance in a game. And then there was no other information I can find, so I'm not sure where that's going. But over the course of all the conversations and investigation into Ryzen, it appears that a combination of memory tuning and threads bouncing between CCXs. So the 8-core Ryzens are configured as 2 quad-core CCXs, or compute complexes. And when threads bounce between them, there is high latency. And some people think that high latency bouncing between the CCXs is what's causing the lower gaming performance. We're not completely sure, but there's still lots of tuning that can happen, and it's definitely a work in progress. It'll be how it behaves. May not be how it behaves in the future. Now, Chris is saying the stream may have crashed, but I'm not sure. Okay, so we're back. I'm gonna keep talking. What do you guys think based on what you saw with Ryzen 7?
Well, what's interesting, and I totally agree with your assessment that trying to analyze and determine root cause of Ryzen 1080p gaming shortcomings right now is an exercise in futility. I mean, sure, if you want to dig in and you really know your stuff, you may be able to find, certain corner cases that, give you a little bit more information about the architecture and what its limitations are. But if you are familiar with CPU architecture, with things like compilers, with just platform validation in a number of apps, in a number of use cases, in a number of workloads, it is absolutely par for the course that when you introduce a brand new architecture to an existing software ecosystem, things aren't perfect. It's just the way it is. Not only that, Intel for over a decade now has been enjoying optimizations on its platform because AMD rather has been so far apart performance-wise that the base level, watermark that everybody, in the software ecosystem chain has been tuning to, has been, optimizing to, was Intel. And so what you do in that situation, it's the software and hardware engineering, partnership that exists in every, whether it be silicon manufacturer or, system level, optimizations for somebody at Intel. It's part of the deal. You hide, you optimize and hide latencies in certain things, and take advantage of your system architecture optimization and advantages you have at the silicon level in other areas. It's just part of the deal. And so to expect this thing is going to hit every peg right out of the gate is really just not cutting them enough slack. The fact that they could hit what they did in the sort of the heaviest workloads, the multi-threaded workloads, with heavy duty, number crunching, things like Cinebench and other, Pavre and other workstation class tools, that's a really good sign. The 1080p, what's interesting to me is that the 1080p gaming thing, I look at it as like, no, that you would think that's easier to fix, right, than the other stuff. If you had a heavy lifting problem, okay, then you've got, IPC issues, right? I don't think we have that here. I think we just have standard issue optimization, platform optimization that has to go on.
I'm not sure, if the way the chip is architected and the way Windows handles scheduling is causing an issue, and it's not going to change. It's just
the flip side. Yep.
It just sort of mars what would be an absolutely awesome launch. So just a couple more quick things that I want to point out before we move on to the other chips. Ryzen 7, in addition to being competitive in multi-threaded workloads and, single-threaded workloads, power was very good, right in line.
Yep.
This part of the scenario, though, is kind of interesting. So overclocking, it's not bad, but it's not great. It's kind of confusing. So if you look at the 1800X as the example, the boost clock is 4 gigahertz. Right, the XFR boost clock up to 4.1.
Yeah,
but right now, because the platform, I'm assuming that this again may change in the future. So right now, your only option with overclocking Ryzen, you can either disable cores to try to push clock speeds higher, or overclock every core. And when you overclock every core, you run out of thermal headroom kind of quick.
Yep.
And our overclocked speed for all cores was 4 gigahertz. So the overclocked all core speed didn't match the XFR single core speed. So
Sure.
That's kind of weird. Like with Intel, you're so used to the chips having headroom. We just talked about a Maingear system overclocked to 5 gigahertz on a Kaby Lake 7700K. So this first batch of Ryzen 7 chips does not have that kind of headroom. Sort of AMD is using every bit of frequency they can without pushing it too far. Now, again, as the process matures and as AMD respins things and new steppings come out, I expect that to completely change as well. But that's another area where it's not just the slam dunk. But overall, this is an extremely strong product from AMD. It absolutely returns them to competitiveness in the high-end CPU space. And it will be, and it's priced competitively. We should also, just mention that.
Yeah.
An 1800X versus 6900K is an excellent value. Same with the other chips in the lineup. And which brings us to the Ryzen 5 series, which is the follow-on to the Ryzen 7. We do not have hardware yet. They are coming next month. The Ryzen 5 series will be comprised of 6-core and quad-core variants. And, these chips, again, are going to be priced aggressively. Completely same architecture, works on the same platforms. They'll probably be paired. So the Ryzen 7 was sort of showcased on the X370 chipset, which is the high-end new chipset. The Ryzen 5 will probably be paired more often with the B350, which is essentially the same, just doesn't support multi-GPU configurations. But again, what you'll see with the Ryzen 5 series processors is more AMD cores versus similarly priced Intel chips. Let me just grab the Ryzen 5 article here. So if you were to look at a Ryzen 5 1400, that's a quad core chip at only 169. But a Ryzen 5 1600X, the flagship Ryzen 5, is a 6-core 12-thread processor for only 249. I mean, that's going to be awesome.
Yep. Yeah, no, absolutely. And I'm actually I'm gonna go back a little bit real quick on you here, and hopefully not stump you with this, but
okay.
I came from the semiconductor world and a semiconductor manufacturer actually, and I always come back to die size with these things. So when you look at Ryzen die size versus Intel's die size, core for core, so let's just say an 8-core versus an 8-core, the 1700 or 1800X versus the 6900, for example. Does AMD have an advantage there? I think they do, right? They've got a slightly smaller die.
So yeah, according to AMD, so if you were to look at, so they reported the die size for a quad core, right? So 4-core 8-thread. Again versus Intel's 14 nanometer. So both produced at 14 nanometer. 4-core 8-thread processor configuration. AMD is 44 millimeters squared. Intel is 49 millimeters squared. The cache size, so 512K of L2, it works out to 1.5 millimeters squared per core, and on Intel 256K is 0.9 millimeters squared per core. Now, if you look at the 8 meg of L3, which is similar across Intel and AMD, so 8 meg on AMD side, 16 millimeters squared, 8 meg on Intel side, 19.1 millimeters squared. So roughly 10% area efficiency, according to AMD, which that's also huge for them. This is the first time in, I think it's like a decade, that an AMD processor and an Intel processor are produced with similar, not the same, because Intel produces their own and Global Foundries is making these for AMD. It's not the same transistors, but a similar lithography size with brand new CPU architectures. This is the first time in like literally, I think it's a decade since the first Core 2 hit.
Yeah,
so it's pretty good.
That's what impresses me. I think probably the most of this thing. Certainly the performance levels are impressive. Certainly what they can get done, price performance. When you think about the price, if you can hit 90% of anything for 50% less, that's like win. That's got to be win, right? So, but what's interesting to me is Intel for years, for almost forever, but when you talk about x86 processors, Intel has been the manufacturing juggernaut. I mean, just okay, we're Intel. If we can't beat them with architecture, we'll beat them with process. Shrink the heck out of the thing, make a bigger, faster CPU, and just throw process at it. They are. I mean, if there's one strength, it's that they are just a process machine, beast. And for AMD to come out and actually edge them, core for core, with slightly larger caches on the L2 and still shave, 10% in spots. That's like, okay, somebody architected this thing really well. Who was the architect that left AMD that set this up? I forget now.
Jim Keller, I think was his name.
Yeah, Keller. Yep, it was Keller. Yeah. So he left, and I wonder about the backstory on that. But man, the team that he led that set this thing up, they did really well. I mean, they killed it, I think.
Yeah, Intel still, like, nobody makes transistors like Intel.
Yeah.
For the most part, for Intel is definitely a manufacturing juggernaut. Yep. Part of that, and I'm just like blowing. I'm just speaking out of my butt right here, but
we don't ever do that
because Intel, manufactures their own chips and they are so strong in that area. It probably wasn't as strong a focus to shrink the die as much as possible. Of course, it saves money.
Right.
It is more economical to have a smaller die. If Intel decided, okay, we want to make the next architecture as tiny as possible, they probably, obviously, they could. They have the engineering. It just wasn't as strong a focus as AMD. It was so constrained over the years that the focus was, small, power efficient as fast as possible in the tiniest area you can, and like that was the focus.
That was the goal. Yeah, it had to be the goal. And that's what's cool about this is they pulled it off. And now we have a serious, credible, competitive threat versus Intel. It's only going to drive Intel to do better, right? This is nothing but goodness for consumers, and it's an exciting time in desktop computing and certainly mobile computing when these things come to notebooks. Paul, are you jonesing for some Ryzen?
I might, just to try something new, but what's nice about this is they brought parity back to the high end, which for years and years didn't exist. And to go back to the 1080p gaming performance, it sounds like lip service from AMD when they say developers need to take advantage of the new architecture, but it's really not, because we saw, and this is not really an apples to apples comparison, but we saw the same sort of thing play out in the browser space. Remember when Internet Explorer had all the market share, and then you had third-party browsers come out that were actually better, but they still didn't run as well or weren't as compatible with some things as Internet Explorer, and now that has changed. Chrome is one of the fastest browsers out there, so it's not inconceivable to think that over time, what AMD is saying is legitimate, and we will see more performance out of Ryzen from developers. I think.
Yeah, I think you're right. I think it's just a question of when you have a developer in house that's concerned about lots of different parts of a system, for tuning for their app, whether it be an application or a game title. You've got the CPU side, you get the GPU side, you've got memory architectures to consider. There's lots of things. What are you thrashing? What resources are you consuming at what times in a certain way? And they're going to look at this and they're going to get something from AMD now that's equally as performant and potent, or pretty much on parity with Intel. And they're going to dig in. They're going to look at what can they do to exploit this thing to the best of their ability. Because
motherboard makers too. I mean, the chipset's going to improve over time. It's going to mature, and you're going to see some faster motherboards out there as well.
Yeah, we have a story up today live at HotHardware. We just got through posting it after 6 o'clock this evening. AMD preps Ryzen EFI update to fix dreaded FMA3 code system lockups. So FMA3 is an instruction set, and there were some lockups. There was some corner cases where Ryzen systems were locking up under certain workloads with this instruction set, and they have fixed that. So they determined root cause and fixed that, and I'm sure they're looking closely at 1080p gaming and looking to solve that one too.
CPU bound gaming. CPU.
Yeah. Marco is right. He's correcting us, and everybody, we've talked about that issue
today.
Yeah, he is. He's like the enforcer tonight. Marco, question about Ryzen 5 is really interesting to me. Again, hitting that price performance sweet spot. What do you think from that family is the best bang for the buck? What's your thought on the processor there to look at?
I mean, it's too early to say until we test it, but I think all of them are kind of interesting. So a 6-core 12-thread processor for $249, I think, is awesome. That's awesome. Now, what this does maybe for some people shopping for a machine, with a processor in that price range, it doesn't mean much. Maybe they do some video renting. But what it does mean is now you're going to drive these multi-core, many-core processors way down in price and make them more prevalent in the market. And now software developers are more likely to develop software that takes advantage of all these cores. Now, we know that was like a focus with DX12 is, multi-threaded gaming to take better advantage of CPU resources. So to drive more cores down to lower price points is, it's a good thing in my opinion. I think that's where software is headed, is taking advantage of many cores. So I think this is all good stuff from AMD. Now, just to go back to the conversation you were having with Paul for a second, if we remember, where we're talking about Intel, and if we remember back when AMD was killing it when the first Athlons came, and AMD was clearly the leader.
Yep.
They awoke that that sleeping giant, and Intel came back hardcore with Conroe and just crushed it. So this Ryzen doesn't propel AMD back into that position. They are far more competitive. They're not in that same position they were with the original Athlon, but could have awoken, the sleeping giant again. And who knows what's going to happen next year? We'll see.
And I hope so. I mean, honestly, Marco, we've talked about this before. What sort of irks us is, Intel's smart. They're innovating. They're looking at different market opportunities, right? And they're looking at drones and the IoT and all this stuff that is so left of field versus what, we've seen them do and what we've come to know and love them for in the core x86, desktop core computing space. It'll be nice if they reset their targets a little bit more back to x86 computing and heavy number crunching versus making a smaller, lower power processor for a drone. Everybody, we're going to need that too. Okay, that's a big market, all that, stuff, and certainly autonomous vehicles and all that. But I don't know, maybe this will put a fire under their butt for back to the desktop.
Even on the desktop side, I feel like Intel's kind of put the brakes on a little bit. I have a 4790K Devil's Canyon, and I still don't feel compelled to upgrade, even though it's 3 generations old now.
Yep.
Yeah, but for a chip that's 3 generations old, I should feel the need to upgrade to something more, but I don't. So I think you're right. Maybe this will kind of push them to fight back a little bit. Wait for Cannon Lake, I guess.
Yeah, it's an interesting thing. And actually, before we wrap up, and we got to wrap up pretty quick, Marco, let's talk about Naples real quick in the data center, where AMD could really bring something interesting as well. And you talk about going right after Intel's bread and butter. Man, the data center is gravy for them. What do you think about Naples and the promise there?
So Naples appears to be an absolute beast. So we've talked about Naples in the past, but just to quickly reiterate, the top of the line Naples platform that AMD is going to come out with is a dual socket setup, and each processor will have 32 cores. So you'll have 64 physical cores, 128 threads. Now each CPU has a quad channel memory setup plus 128 PCI Express lanes. So you're talking about huge CPU compute resources, tons of low latency IO, and massive amounts of memory bandwidth. And although pricing wasn't disclosed, AMD did say they are sort of going to be aggressive in the enterprise space like they were in the consumer space with Ryzen. So if you were to compare what Intel's flagship 2P setup today versus the Naples setup that AMD has proposed, you're talking. Let me get the numbers just right here. So, but the 2P Naples setup, up to 128 threads versus 88 on the Intel side. So 32 core CPUs versus 22 core CPUs.
Yeah.
Twice the memory bandwidth, also on twice the memory channels on the AMD side. Plus AMD supports higher memory frequencies as well. And then you also have more PCI Express connectivity from the CPU. It's just it's a beast of a data center setup. Now we don't know where clocks are going to be, with 32 cores on in the processor. But assuming AMD gets clocks where they should, you're talking some crazy powerful setups. Like you could virtualize like quad cores for a whole bunch of users on a single server, or just have massive amounts of compute for HPC workloads. It's just a beast of a server platform.
Yeah, that's what struck me about this thing is you talk about more cores, 32 core versus 20 core in the Xeon, 32 core per socket, so 64 cores total, 128 threads with multi-threading. 8-channel memory controllers, dual 8-channel memory controllers, right? So you can load this sucker up, and you've got theoretically, at least twice the memory bandwidth. You've got a whole bunch more threads, a whole bunch more cores to throw at it. You've got, interestingly enough, you've got AMD's strength and serial connectivity for the Infinity Fabric that they connect the CPUs in the system, making available more PCI Express lanes, free available PCI Express lanes off the CPUs downstream for I/O connectivity, whether it be GPUs, whatever you want to throw in there. This thing is plumbed, right? Plumbed to the gills. And, whether it be memory bandwidth or I/O connectivity, not only do you have a bunch of cores, but you can get at them, and they can get at memory. And so it's just like, holy crap. I mean, it's really an impressive looking platform. I can't wait till we get our hands on it. And then, right, the rumor comes out, you heard this too, Marco, that maybe there's a 16-core Ryzen. There's a rumor floating around that there's a 16-core Ryzen going on out there with, instead of dual channel memory, quad channel DDR4, which would get them much more memory bandwidth there. We know they were able to achieve dual channel close to what Intel did with quad channel memory, right? I mean, very close, within like 10%, right? Memory bandwidth?
Well, memory bandwidth is good. Memory is still an issue where AMD is definitely tweaking, and motherboard makers, like as the BIOS, the firmware updates come for motherboards, that's definitely an area of focus right now. So where they are now will probably change. But yeah, AMD has done a fairly good job across the board here, except for the issues that we've already spoken about.
Yeah, I think they're just getting warmed up. I think there's room for improvement here, as one would expect. But yeah, the 16-core Ryzen chip is interesting. We don't know if it's necessarily a Naples derivative or if it's just a double 8-core Ryzen derivative.
It would probably be harvesting the dies that didn't make it into the Naples land. Getting 16 good cores. The ones that don't quite have 32 cores available to them. Now, right. For the people watching us on YouTube, if you want to see something nuts, search for a video we posted last year of a Xeon server. It's a dual socket Xeon server running Cinebench, and I forget exactly how many threads I had running. I think it was 80. I think it was an 80 thread setup or a 78 thread setup. And you watch, all the boxes fly through the Cinebench benchmark and go, holy crap. Now picture 45% more boxes churning through a multi-threaded workload like that. It's nuts. It's going to be crazy. So AMD is really, as strong as Ryzen looked on the desktop, Naples is looking really strong for data center. Yeah. Again, making assumptions that they get clock speeds and power and pricing and platform right. We're making assumptions, but it seems like they have something strong there.
Yeah, we should quantify that. It's certainly on paper. These are the specs we're being given, and when you extrapolate from the specs, you come up with a certain performance expectation that looks like X, right? But if you look at the memory bandwidth availability, the number of cores available, the I/O connectivity, this thing should kick some serious ass in the data center, and really. That's where it will. I mean, you talk about hurting Intel on the desktop. The data center is a cash cow, and if they can step up with that, and that thing is as real as it looks on paper, Intel could. I mean, that's really going to turn their head.
And even if they don't kill it, right? AMD's market share in enterprise servers today is basically zero.
Yeah.
There's no Optane business to speak of anymore.
Yeah.
So there's potential for them, even if they don't take a huge chunk from Intel, to make some big coin, which will be good for the company.
Yeah. Well, it's interesting. Their stock was in the tank, below $3 a while back. It's now up in the $14 range. Today was a tough day in the market. Everybody slid. They're down a bit today, but I think they're in for a bit of a run. Matter of fact, I had a financial analyst guy that I know, a good friend of mine, who actually was recommending a buy. I wouldn't recommend anything, wouldn't give any stock tips, not my gig, that's for sure. But it's interesting that they're back, their stock's back, the company's back, they're a little bit healthier cash wise, I'm sure, as a result of that. And good stuff, good competition, good for us all.
Yeah, man.
So I think we get a wrap, but let's talk real quick about a contest giveaway that we have coming up. Why don't you share some details on that, Marco? Because I was just yapping too much.
I think you should probably share the details because you just had a call on this, didn't you, a few hours ago? I don't want to say the wrong thing. You just had a call.
So we will be in the next probably within the month of April, very soon in the month of April, first week of April. Think about that. We will be giving away a very nice gaming notebook from the folks at Razer. Stay tuned for details on that. We will have our usual post up at HotHardware.com, which will talk about the rules of engagement, and there will be a little bit different ones. I think it's going to be a little bit more socially in this giveaway, but you could win some really cool gaming hardware powered and infused with killer networking on board. We're in conjunction with the folks at Razer and Killer Networks for their gaming NIC technology, low latency bandwidth provisioning, gaming NICs. So check into Hot Hardware for that. We will have that up probably in the next few days. We're going to kick it off first week of April, so next couple of weeks. Check us out at hothardware.com. We're at facebook.com/hothardware, twitter.com/hothardware, youtube.com, where you're probably hopefully watching this, and we encourage you to thumbs up and subscribe. We'd appreciate it. Hot Hardware Vids on YouTube. And we're on Google+. We're everywhere, like the scourge of the internet. We always say that. What do you think, Paul? Are we scourgy?
A little bit, at times.
That hat and shirt combination is scourgy, man. You rock that.
You like it? Yeah.
Marco, any words of wisdom before we part? Should we go out and all buy Ryzen systems right now?
All go buy Ryzen systems? Of course not. But if you're looking to build a new rig, go have some fun. Buy an AMD rig and an Intel rig. Friggin' let's get the desktop PC and gaming PCs kicking ass again. Overclock those some bitches. Let's do some fun stuff.
No shortage of enthusiasm there. Thank you. Yeah, I appreciate that. Good stuff.
Yeah, I think I'm going to build myself a new rig, and I'll do a build video and have some fun with that soon. We'll see.
You need to. Aren't you on like Ivy Bridge?
Yeah, and my machine is flaking out. I'm still on Ivy Bridge, and my machine started throwing errors yesterday, and it's on its last leg. So I need to build something, and I'm going to try to do something quick. Maybe I'll stream some of it, and we'll make a fun video out of it. We'll see.
You should treat yourself. And Real Neil chimes in the chat. Oh yeah, a new contest. Neil, good to have you with us, buddy. We like you having you around these parts. And yeah, check in. We'll have a giveaway soon. And thank you, everybody. Thanks for stopping by. Hit it.